Hello, Heritage Academy geometry students, and welcome to another incredible edition of Geometry, Seeing, Doing, Understanding. This is Lesson 3.2, the Ruler and Distance, Part 1. That's right, there are 2 video lessons for this particular lesson, so make sure that you tune in to both. As always, this presentation is brought to you by me, Mrs. Elzagary, PowerPoint, and the Internet. So as mentioned before, the first part of this lesson in this video, we are going to take a closer look at the Ruler Postulate and distance between points and how to measure those distances. But before we go any further, let's explore our ultimate objectives for Chapter 3 and our intermediate objectives for this lesson. So we know that Earth and the universe, which were created by God, have remarkable evidence of geometry, and that God uses lines and angles beautifully and systematically in all kinds of living and non-living things. Now, lines and angles are really important to us, even though we don't always think about them or pay attention to them. And because lines and angles are created by God, understanding how they function supports our understanding of our Creator, which is super cool. So let's talk about our intermediate objectives. Today we're going to define the Ruler Postulate. We're going to define the betweenness of points on a line. We're going to use the Ruler Postulate and betweenness of points to explore distances between coordinates placed on lines. And finally, we're going to write a 2-column theorem using direct proof. Once again, this is lesson 3.2 on pages 84 through 86 in your textbook. Remember, this is part 1 of 2 video lessons for this particular lesson. So get your Cornell notes ready. Definitely have a super sharp pencil because you are going to need it. So what does math have to do with devouring a sub sandwich? Well, let's find out, shall we? So imagine that we want to split this bad boy up into different sized pieces so that we can eat them. We could talk about the length of this piece here. We could also talk about the length of the second piece in our picture. We can see clearly that they're different lengths, but that they are right next to each other. Now, we could also talk about the length from the first sub we cut to the second sub. We could also imagine that every spot where we've cut the sub could be a point on a line, as shown. And we could actually give those points labels A, B, and C. Now that we've given them labels, we could also think of them like coordinates on this one dimension, on this line. So let's just say that from A to B is 6 inches. So we've cut a 6-inch sub. And from B to C, we've cut a 9-inch sub. Could we talk about the total? Sure. Between the 2 subs, from A to C, we can add those and find that we have 15 inches of sub sandwich altogether. Now, imagine that we know that the length from A to B is 4 inches, but then we are not given the length of the second sub. Instead, we're given the length of both subs from A to C. So take a look at this. If the length of AB plus the length of BC equals the entire length of AC, then we can also say that AC minus AB equals BC because of our math properties that we already know. Therefore, if 4 inches plus X equals 12 inches, then 12 inches minus 4 inches equals X. And we could find out that the length of B to C, or our X value, is 8 inches. Now, another way that we can look at points on a line, besides A, B, C, and so on, is to give them a value. So when a point corresponds directly to a number, we can call the point a coordinate. So let's say that A is sitting on the number 5, and B on 9, and C way up there on 17. So coordinates in one dimension, that is on a line, are going to show us distance. So Now we can talk about the distance from A to B. So if A is at 5 and B is at 9, we can use subtraction, 9 minus 5, to figure out that there's a distance of 4 in between these. Same goes for B and C. If we want to look at that distance, we can subtract 9 from 17 and find there's a distance of 8 in between them. We can also extend this thinking to multiple points. So we can look at A going all the way to C, and that is a distance from 5 to 17. So the difference would be 12. Now it's important to note here that the distance between coordinates is always positive. We aren't going to go into the negatives here, because if we were in the negatives with distance, we wouldn't have a distance. So wouldn't it be great if we could just take a ruler and measure the distances between these points? Well, you already know from previous math classes that usually this isn't the case, and it's not how we measure these points. So this brings us to a key idea in this lesson, which is the ruler postulate. So remember, a postulate is something that we just assume to be true without necessarily having proof. Now this postulate states the points on a line can be numbered so that positive number differences measure distances. So anytime we have that coordinate and we've assigned a value, we can talk about the different distances between points. Whoa, that was a lot of information. So let's break it down a little bit. We've got some points on a line here, A, B, C, and D. Now I can put dashes in between those points, as you see here, and say that B and C fall in between A and D. We can also give values, and if we give a value to a point, then we can call it a coordinate. We can also talk about distance between these points. So we could talk about A to B, or A to C, or A to D, and so on. And finally, we can also talk about how these coordinates have different amounts to them. So A is less than B, B is less than C, C is less than D, but look at this, we can also put 3 of them together and say A is less than B, but B is less than C. So using inequalities to compare the value of a point on a line suggests a way to define what it means for one point to be between 2 others. Now, this brings us to an important definition in math, where we say a point is between 2 other points on the same line if and only if its coordinate is between their coordinates. And we call this the betweenness of points. It doesn't sound very formal or anything, but that's what we call it. So then take a look at this. We can say that if B falls in between A and C, if and only if A is less than B and if B is less than C. And here we're using lowercase letters to stand for the value of a coordinate. Now, everything that we have done so far in geometry has brought us to this point. So this is a really exciting part of our geometry journey. We're going to take an actual theorem, the theorem of betweenness of points, and we're going to look at the simple steps that brings us to that theorem using direct proof. We're going to really dig into this deeper in the second part of this video, but for now, I want to just walk you through some basic ideas for how we can construct a theorem so that when we get to that second video, you're feeling a little bit more like you know what's going on. So the theorem of betweenness of points looks like this. If B is in between A and C, then the distance from A to B plus the distance from B to C equals the total distance from A to C. And this makes sense when we look at this number line that I've put on the screen, because we can look that the distance from A to B we know is 5. The distance from B to C we also know is 5. And it makes sense that 5 plus 5 equals 10, but we can also see that the distance from A to C is from 5 to 15, which is also 10. So the idea here is that when we write steps for a direct proof of a theorem, that we follow a certain structure. And that structure is something you already practiced in chapter 2. So let's break it down into some really simple steps for you. The first thing that you want to do when you're writing the direct proof of a theorem is to find the hypothesis of the theorem, which you already know how to do. Our hypothesis for this theorem is if B falls in between A and C. The second step is to determine the conclusion of the theorem. So the conclusion for this theorem says that AB plus BC equals AC. Once you've done those two things, then you're ready for step 3, which is where you're going to write a series of conditional statements in the form of a syllogism. And you're going to start with the theorem's hypothesis and end with the theorem's conclusion. And the whole idea here is that you're trying to prove that this is logically true using math facts. Often we're going to use math properties to do this. So this is why we took a look again at those math properties in the previous lesson. So a key thing to remember as we go through this process of writing a direct proof is your basic syllogism form, which looks like this. If A, then B. If B, then C. Therefore, if A, then C. I hope that showing you the simple steps of writing a theorem broke it down a little bit for you so that you can start to make some connections between where we've been in math and where we're going next. So don't forget to tune in to part 2 where we actually dig in deep and write this direct proof. I will see you there.